Hello, how are you? Good morning, good afternoon, good evening. Let's get our cup of coffee and start. We continue with the realization of hacks to solve it, reminding them that the team of your ET is making this material to solve doubts of yourselves who have sent us and to make it more efficient to remember that information important to solve in a simpler and more efficient way. The perfect integrals in this case, an integral where the same identical can be found in the form that, for example, if you search your form either printed digital x breast integral dx does exist, agree by sin of x, I mean that we can also put x minus cosine of x, etc. In this case, I am referring to a function trigonometric. Okay, perfect, very good. In the realization of the previous episodes of the different exercises we have done together, we have noticed and emphasized that within an integral, we need one u and one u, agree, perfect. Then when we have a direct formula to solve an integral, in this case, it is a very simple and very fast way to agree because we have exactly the same in the form agree very well. In this case, changes the u and du part a little bit, okay? What would be our u in this case if we have a sine of x, our u in the functions? Trigonometrics is going to be the part between parentheses, the mirror part, okay? If we had, for example, let's put with blue, we would have another example, another trigonometric function. We would be with sine of x. What would be our u? In this case, would be the x, nothing more. Agree that the part of paradise, the part inside the parentheses, is our u. When we are going to apply a direct formula, then what would be our du? Let's see. Let's put it on this side. Our u in the bosom of x, what is it? The x, and what would be the our du would be x, I agree. And now it is doing the delicious checkout. We have everything complete. We have the x, obviously we have the dx. Yes, in this case, if our u is x and our du is x, we have it complete, and that is why we can apply it. The direct formula is chosen directly from the form. Okay, very well. In the case of cosine, for example, cosine of x is exactly the same process as ours. U, we already know what's in the mirror, que es la x, our u is the e, and our du would be the x, agree. We have it complete. Let's review from x to x. Okay, then it is possible to apply a direct formula. It is also possible, well, another part that confirms this, which is a direct formula, remember that we have mentioned in previous episodes, has to be exactly the same if we found the integral that we want to make identical on the form. It is possible that we can directly use it. We must check that we have the du, or the complete differential is the only thing we need to review. And in this case, you could say, well, what is our u? Our du. In this case, our u in the functions trigonometrics is the part between parentheses, okay? In the functions trigonometrics is the part in parentheses, that part is ours, u, okay? It should simply be derived. Could be, for example, 2x sine within something else and involve the x, yes, integral the way the seno of 2x for its dx. We already know that. Having a function trigonometric which is ours, or the part which is in parentheses, yes, our u is equal to 2x. And our du is equal to what? At 2 dx, very well. Let's move on to review. We have the dx. What we are missing, and we are only missing 0, 2. Then, as we already know, we are going to add it. We are going to put integral. We can place it at the beginning or immediately from the dx. It's okay, remember, you are multiplying, and it's really okay where we place it would be within 2x and add 0, 2. Let's put it in a different color, 2 for the dx, which is already there. If you look at it, we already have the full differential. Do you agree? 2 dx, that this part we have here, and we can now apply the direct formula very well. Part of the doubts that the students have told us about all the people who watch the videos of Your Wit is that they have certain doubts when they have a trigonometric function. I want you to remember, as long as when they have a trigonometric function, the trigonometric function is composed of the sine, cosine, or the trigonometric function itself, but also with yellow. And that is the complete trigonometric function. If you have breasts of x, remember that this part of the mirror that is in parentheses cannot be separated of the breast. In this case, in this example, yes. If they had, for example, diamond the x cannot separate this x or that, which is in parentheses on the front, okay? The function trigonometric. I want to make it clear that it is complete, never separates, yes, never changes, okay? Very good. In this case, to where we have seen to the resolution of integral exercises, I want to make it clear that this part never. separates the trigonometric function part is complete bosom of the old cosine of the old. Yes, we are clear. Then we already know that when we have a function trigonometric part, which is in the parentheses in our u, and we simply have to find our du and try to complete it. You agree very well. Then remember, the only thing we can add to complete a differential are numbers. We cannot add variables, and we cannot add another function, trigonometric. Yes, it would be like a water part to see if we can use the direct formula or disagree on the case previous. Right now in the example we have just made, we are one too short. Then we could add it because it was a number, and in this case it was possible to, by a direct formula, agree very well. And what happens then when we have, instead of a trigonometric function, if we had Euler number at x agree in this case? Euler has a separate exponent. Yes, that exponent always goes together with the, it can be 2xx squared, etc. Yes, but in this particular case, when we are going to integrate the x or Euler number at x or at any power, our u will be the exponent, and we are going to have to obtain our deo agree. And what happens, for example, in the event that we had logarithm of x, this is together as in trigonometric functions, as in the case of the number of Euler, who has an exponent and who goes together, are glued together. Also logarithm of x, this goes together. It is not possible to separate the logarithm x, okay? And in this case, which would be ours or ours, u exactly is the part in parentheses, the part that goes with the logarithm. Okay, when we are going to integrate, it is necessary to derive what's inside of the parentheses in the case of the function trigonometric, because what is in the part when we use, or we have Euler number, the exponents part, as well as what is between parentheses with the logarithm. And as a rule, as simple as it is to remember that what is in parentheses always goes hand in hand with the function trigonometric with logarithm, or with number of Euler never separate. And there the du, we get it by deriving the u, and in this case of these three examples, the u. What is in the parentheses? Okay, very well. Remember that the team of Your Wit is trying to and aims to perform these hacks, this part, to remember information that is important to solve, integrals, especially to make it easier for you at the time of exercising to pay attention to watching the videos or try to keep up. Remember that information, which is information that you all already have, yes, or are they learning? Okay, I hope this one is clear. Hack, take care of yourselves, drink coffee. See you at the next one. See you later.